Eric here from Laser Scanning TV, and in this episode we're speaking why it makes sense to have a GPS receiver in your SLAM scanner. Why it makes sense to having a GPS together with your SLAM device. We have over many years a SLAM scanner on the market, and of course in the past there was few integration. This is maybe the most advanced integration from CHCNAV. Is a GPS receiver with a SLAM unit together as a survey instrument. Why it makes sense to combine a GPS system with your SLAM. You see, I'm outside here, and if you like to use your SLAM device to make a topographical capturing, because maybe this bus stop should be renovated, the design engineer need your data, not local. He needs in global coordinate system. And your GPS receiver gives you a global coordinate. That's why it makes sense on this point to have an integrated system with an RTK service. We in Europe, we have very good RTK services. You instantly measure in the coordinate measurement system. And here in Germany, we can achieve like 2 centimeters for the horizontal accuracy and maybe 3 times more, up to 5 centimeters in the vertical accuracy of your system. So this means you can immediately use this for topographical capturing, for maybe a volume calculation, measuring in mining application. Very easy, you have all here integrated. Then another way, it's typical you're using for the SLAM process. This means simultaneous localization and mapping. You're sending a lot of data out with your SLAM device, and the system calculates your orientation in the area, and at the same time he captures the area. If you have like an open area like here, and you not have so many good 3D features, like we have here a lot of trees and bushes, but it can be that you maybe more in some areas like in deserts or like in big construction site where you only have flat areas, you not have very good 3D features for your SLAM calculation. This means for the calculation for the trajectory. With this integrated GPS device, your system every second measured one position. This means your trajectory calculation get every 1 second a right point where it should be. And the system can use this GPS information together with the SLAM in one process, and you get a very accurate measurement in areas where SLAM conditions are maybe not the best one. That's another point. And a third point, what you have is in the traditional way, without a GPS integration in your device, you have to making usually a measurement with a loop closure. This means you start from this point, running the whole area, capture everything, and coming back to the same points. And the system can see how the trajectory drifts over the time if you come back to exactly the same point. This means this is your inaccuracy, and the computer process with the loop closure a correction for all your measurement and make it more correct. With the GPS integration, you don't have so much drift because you have this permanently GPS position what gives you a stable trajectory. This means you don't have to do a loop closure every time. You can make only a measurement going one way and don't have to come back. And this is make your measurement very efficient. If you are maybe on a construction site, you have only go this area one time, or in an open pit coal mine, and don't have to come back. So that's make your measurement also very efficient. Yeah, I see that's for me the 3 most important points is: 1, if you like to measure in global coordinates, make it sense to have a GPS together. A better measurement if you have poor condition for the SLAM tracking. And the third one, you have to go only, you can use a single way. You don't have to do every time a loop closure. This is 3 advantages what I see, but maybe there are some more advantages, and you have this in your head, then put down this here in this commentar section. And the last point, what I like to speak to, which antenna. So that is for me the most interesting application in the moment, is this GPS receivers together with the SLAM unit. And here we have a flat GPS antenna and a very precise. CHCNAV produce over 20 years GPS receivers, have a lot of experience. But you see also other SLAM scanners, they have as accessory like very small antenna, very small receivers. They're looking maybe like a lipstick something. We call them as a helical GPS receiver, and that's just a big GPS receiver. For my understanding, is a bigger receiver, the bigger antenna, the better choice, because this antenna in the middle, you have your ship inside, and the flat area keeps out bad signals. Usually the GPS signals come everywhere, come to us, your antenna, but it came also to sidewalls, to the ground, and it gives some information. Some signals can become also from the ground, and we call them this multipass effect. And this gives you mostly poorly information. That's not the best accurate measurement data. So this means a more advanced, more flat receiver like this one should give you a better GPS signal and a more accurate measurements. That's in theory. We not checked this yet, but we will trying to do this in the future, giving you the idea. Maybe one point is important with SLAM devices is not only all hardware, many is also regarding how you measure, how the software calculate the algorithm, how the area is for SLAM scanning. But I think that is a very good and very clever idea what CHCNAV does here. But of course there are also other producers who have integrated GPS receiver, and I think, for my opinion, for measuring outside will be this the way to measure in the future. So I'm ready with this topic. I hope you like my this presentation from my side, and don't forget to subscribe to the channel, leave a comment or give me a thumb up. Bye bye, Eric.